Hello students, let's continue with your lecture 2 for total internal reflection, exercise 4D of chapter 4, refraction of light. Okay, now already I have introduced the two topics. I have explained you total internal reflection and critical angle. Okay, now we are going to continue with the same, and now we are going to specifically talk about total internal reflection in different types of prism. Okay, you must see the small demo which I have sent you, okay, of the same total internal reflection, where we can very clearly see that as long as the angle of incidence is less than critical angle, the light ray gets refracted. We all know in total internal reflection, light travels from denser to rarer medium. It bends away from the normal. As we are increasing this angle of incidence slowly, what happens? There is a time when the angle of incidence becomes equals to critical angle. In that case, we can see very clearly that the angle of refraction was 90 degree. Further, if we increase the angle of incidence in denser medium and it becomes more than the critical angle 42 degree, which is for the glass, then in that case, what happens? Very clear beam of light ray you must be able to see in the demo that it gets totally internally reflected back. Now let's talk about the ray diagrams of the same. We have few ray diagrams, very important, which I'll be discussing in today's class. Okay, let's start with the first one, students. Here it is. We have an equilateral prism we are talking about. In equilateral prism, it's exactly same as that of equilateral triangle. When I understand what happens, each angle of the triangle is 60 degree, right? So here, this AB is the incident ray. This angle Q is 60 degree. Since the light ray falls normally to the surface PQ, the light ray falls normally 90 degree, making a 90 degree angle. What happens? This angle also becomes 90, right? 90 plus 60 is 150. And total sum of the three angles of this small triangle is 180 degree. Of any triangle, it's 180 degree. So 60 plus 90, that is 150 degree, and total sum is 180. So subtracting from 180, what do I get? This particular angle comes out to be 30 degree. Okay. Now, is this angle of incidence, students? No, I have explained you in the previous class. This is not angle of incidence. Why? Because it is the angle, it is not the angle between the normal and the incident ray. Okay. If this angle is 30 degree, then we know that Cn is again another normal. The moment the light ray strikes the surface, what happens? This angle is 30 degree. So what will be the remaining angle? 60 degree. And by laws of reflection. Why laws of reflection? Students need to understand here very clearly. Here, the angle of incidence was 90 degree. Normally, whenever the light ray strikes a surface, what happens? It goes straight. It goes undeviated. It goes straight. So that is how it entered. It strikes this particular surface. This is the point of incidence. At this point of incidence, Cn is the normal. This angle of the incident ray with this surface is 30 degree. So the remaining angle, that is the angle of incidence comes out to be 60 degree. Okay. Now since this angle of incidence is 60 degree and the critical angle for glass prism is 42 degree, that means the angle of incidence is greater than the critical angle, which is given as 42 degree. And whenever that is the case, what happens? The light ray gets totally internally reflected back. How will it get reflected back, students? It will follow the laws of reflection. Angle of incidence was 60, so angle of reflection will also be 60 degree. This ray diagram I have drawn for you all. Must pay attention. See, this was 90 degree. Normally the light ray was incident. So whenever light ray strikes the surface normally, it goes straight, undeviated. It goes straight, undeviated. This angle of prism was 60 degree. Equilateral prism we are talking about. This is 90, so this remaining is 30 degree. If this Mn is the normal that I have drawn, then this angle comes out 90 minus 30, that is 60 degree, and that is the angle of incidence. Critical angle, very clearly students, it's 42 degree. So when the angle of incidence 60 degree, we can very clearly see is more than the critical angle, what happens? The light ray will get totally internally reflected back, making an angle of 60 degree again, because by laws of reflection, angle of incidence is equal to angle of reflection. Now this is 60. So what is this remaining angle, students, since it was the normal? Yes, it comes out 30. What was this angle? It was equilateral prism. It was 30. It was 60 degree. 60 plus 30, that's 90. Again, this is a small triangle. Sum should be 180. 60 plus 30, 90. Total sum 180. So what will be the angle this emergent ray will make with the surface BC? That is 90 degrees. So this is how the incident ray strikes the surface and comes out straight, making an angle 90 degree with this particular surface. This is the incident ray PQ and this is the emergent ray RS. This ray diagram along with its uses, properly angles must be mentioned, because without that in the ray diagram you won't get the marks in your exam. So this is must. Hope you all have understood. Sure. Let's move to the next. Now here I'm going to talk about 45, 45, 90. If we have a triangle such that two of its angle are equal and one is 90 degree, what do we call it as? Two angles are equal in a triangle, isosceles triangle. One is 90 degree. So isosceles right angle prism, students, we are talking about, okay? Because we are dealing with the prisms only. So it is isosceles right angled prism. At times what we do in exam is we give this as 90 and these two angles we don't mention. But what we give is AB is equal to BC. So apply maths. We all know what? That if AB is equal to BC, then the angle opposite to equal side are always equal. This is 90, sum of 3, 180. AB is equal to BC. So each will be equal. Angle C and angle A both will be equal. Each will be 45. Fine. That is one of the board question, one of the important question that I was talking about. Let's talk about this ray diagram. Now what happens? AB is the surface. Okay. One of these lines, perpendicular line, what are we doing? The light ray strikes normally. Again, this is 90. So what will be this angle? It will be 90 degree. Since we are talking about the isosceles right angle prism, this angle is 45. This is 90. So this incident ray, as it was striking normally, it goes straight undeviated, makes an angle of 45 degree with this surface AC. Perfect. Now let's make a normal at this point of incidence. This was 45, this is normal, so remaining comes 45. Critical angle, we discussed in the previous slide. What it is? Yes, critical angle was 42 degree, right, for glass prism. So what we will have? We have now the angle of incidence is more than the critical angle. Once again, angle of incidence is 45 degree and the critical angle is 42 degree. So it is more than that. What should happen? Total internal reflection. So internally the light ray will get reflected back, making what angle? Again, by laws of reflection, angle of incidence should be equal to angle of reflection. So this will also be 45. Now as the ray come out, this is 45, so the remaining part becomes 45. This angle is 45 because it was isosceles right angle prism. What will be the third angle, class? Yes, it will be 90 degree, because sum of the three angles of a triangle again is 180 degree. So this is deviation through 90 degree. Why? Because this is how the ray strikes and this is how it emerges out, making an angle of 90 degree between the incident ray and the emergent ray. So 90 degree is this. Clear, students? So this is the second ray diagram. Again, ray diagram must be drawn along with the angles measure. All written, arrows are must in the ray diagrams, and at the same time uses must be written very clearly. Clear, students? Let's move to the next. Yes, here I have again isosceles right angle prism, but the way I have placed it is different. Okay, now at this surface where we are having these two base angles equal, this particular side BC's face, if the ray strikes normally, this was 45, this becomes 90. What will be the angle? 45. Again, it is striking normally, so it will go straight, undeviated. The moment it strikes here, draw the normal. This is 45, so it will also be 45. What will happen? Since critical angle was 42 degree, more than this, the angle of incidence 45 degree, so it will get totally internally reflected back. Now again it strikes the surface. How it strikes? Making an angle of 45 degree, this particular. This is 45, so this will also be 45. Students, this was 90 because isosceles right angle prism we have taken. So this angle remaining comes 45 degree. What is again the angle of incidence, angle between the incident, the normal and the incident ray? It is 45. So again more than critical angle. So it will again get totally internally reflected back, and this is how the ray emerges out. Okay. This is 45. So this is 40. This will also be 90 minus 45, 45. This is isosceles right angle prism. So 45. So how this ray will emerge out? It will make an angle of 90 degree with the surface and will emerge out. So what happens? It is a total of, yes, 180 degree. So what can we do with this such kind of positioning of this right angle isosceles prism? Yes, we can get the erect image of an inverted object or the inverted image of an erect object, right? Let's see in the next slide the same. See, I've taken AB as the incident ray. There it was a point object, point ray. So that is how we have to consider it. Now, if this is the object, AB is the object, it is kept erect. First incident ray strikes, following the same, and this is how it emerges out. Second incident ray from this end B strikes because it was 90 degrees, so undeviated goes straight. Now again following total internal reflections in the angle of incidence comes 45 degree more than critical angle 42 degrees, so again it emerges out. Join these two, what we get is this is the inverted image of the object. These were the two incident rays, these are the two emergent rays, which clearly show us that if AB was the erect object, then the image formed was inverted by the emergent rays. So this particular concept also should be understood. Ray diagram must be drawn and the uses must be written by you all. Now there are a few important points which we are going to talk about, students. Be very clear, pay attention, because these are also part of exercise questions, some difficult questions I have taken today. Okay, so you must take care and understand these points very clearly, and your homework at the end of the lecture is going to be again the same, to complete the back exercise question answers, which means exercise 4D, all the question answers you will go through. The ray diagrams which are to be drawn in book, you will draw it in book. Okay, I'll discuss those particular solutions which are to be done in the book itself, ray diagrams, in the next class. And the question answers must be marked in the book. Don't write these all definition everything again, because already in notes form I have told you to write it in the previous class. And today's class 4D exercise, all the ray diagrams which I have shown you on the slide for today and the previous ones, with the uses of all the 3-4 cases I have discussed today. Fine. Now the important point is, as the wavelength decreases, refractive index becomes more. Wavelength is decreasing, that means refractive index, what happens? It increases. So how are the two varying with each other? Refractive index mu and wavelength. This I have discussed in chapter 4 in ABC exercise previous. Earlier also we discussed it, right? That the two are reciprocal of each other. They are inversely proportional to each other. Mu, the refractive index, and the wavelength lambda. Okay, they are inversely proportional to each other. And critical angle becomes less. Okay, so this is very, very important point we need to understand, because this is how we are going to relate. We know Vibgyor, violet, indigo, blue, green, yellow, orange, red. These are the 7 colors. When we talk about, then they are arranged in the order of increasing wavelength and decreasing frequency. These two I have explained you. Fine. So for red light, the critical angle will be more than 45 degree. Okay, at times the question is actually asking specifically about a particular color. So for red light, critical angle will be more than 45 degree, and for the blue light the critical angle will be less than 45 degree. How am I able to conclude these 2 points? Only on the basis of this concept. It is actually important concept and is there in your exercise too. So you must make a note of this particular as a important point only in your registers. Okay, since I've told you not to do the back exercise question answers all in register, this as an important point you can write in your registers. Okay, fine. Let's move to the last point. It is the factors which affect the critical angle. In the last class, 2 conditions for total internal reflection I discussed with you all, right class? Now in this particular we are talking about the factors which affect the critical angle, and they are: number 1, the color or the wavelength. Just now I had a discussion with you in the previous slide, right? So the first is effect of color or wavelength of light on the critical angle. Second is the temperature. How? Let's understand. Again, this is an important question in the exercise also, it will be there. So you must make a note of this too as an important point in your registers as a homework. Effect of color of light. Let's see the first point. The critical angle for a pair of media is less for violet light and more for red light. Thus, the critical angle increases with increase in wavelength of light. Next point, that is temperature. How it is dependent on critical angle? Let's see. The critical angle increases with increase in temperature. Okay, how are the two related with each other? Temperature and critical angle. The critical angle increases with increase in temperature. Yes, students, the two are, if one increases, the other increases. They are directly proportional to each other. The critical angle increases with increase in temperature because on increasing the temperature of medium, the refractive index decreases. So this is actually an important point. Must be written as it is in your register in the form of notes. Okay. So this was all. Thank you for the class. And next lecture we are going to continue. Okay. I'll be taking the back exercise ray diagram questions. Okay. Solutions I'll be sharing with you. So you all must be done with that today itself. Okay. And then when I'm going to share the same, those ray diagram back exercise solved questions with you, you must do the corrections in case needed. Okay. Other than that, back exercise question answers, you must mark all in your books. Notes of today's class must be written properly in your registers, ray diagrams along with their uses and the line written below that, deviation through 90 degree, deviation through 180 degree to get the inverted image, what all like that. Okay. So it is, the homework is to complete what all? The ray diagrams. So it is to mark back exercise question answers in books and draw all ray diagram in register along with the uses properly written, what you are doing, what is the, what are the important angles to be mentioned in it as I've shown you in this particular video, and the uses. Okay. Revise all contents very clearly. Book back exercise and book line to line reading is must, students. Thank you.